All right, section 7.4, approximating square roots. We're going to start by talking about how to classify numbers, and there are two types of real numbers. Now, we know there are non-existent numbers. We'll talk more about those in a second. We've already mentioned a couple of them in our earlier sections. But real numbers can be classified into either being rational numbers or being irrational numbers. The numbers that you are used to working with, first of all, you've all worked with real numbers. You've never worked with non-real numbers. Okay? But the numbers you're used to working with are rational numbers. You've got lots of different types of rational numbers. A rational number is any number that can be written as a fraction. Some definitions say ratio. That's a fraction. So let's list all the numbers that can be written as fractions, and they're all rational. The first fraction you ever learned was a proper fraction. What does it mean to be a proper fraction? Carter?
It means that there's no, you can't turn it into a mixed number.
That would be correct. You can't turn it into a mixed number, meaning the top number, the numerator, is smaller than the denominator. Okay. You've also got improper fractions. Improper fractions is where the numerator is larger than the denominator, and those can be turned into mixed numbers, which is our next one. A mixed number can obviously be written as a fraction. Also, integers can be written as fractions. How do I turn the number -8 into a fraction? Owen? Put it over 1. That's exactly right. You turn it into a fraction that way. Next one. Terminating decimals. Those are decimals that stop. They can be turned into a fraction, like 0.5 can be turned into 1/2 or 5/10, which is 1/2. Okay, 0.77, 77 hundredths. 0.125, 125 thousandths. If it stops, you can put it over a place value. Not all decimals stop, however. Some go on forever. Now, if your decimal goes on forever and it repeats, so it's a repeating decimal, you can also write those as fractions, and I'm going to show you how to do that tomorrow. That'll be our last small little lesson before we have our quiz on Friday. A repeating decimal you're probably familiar with is that 1/3 is 0.3 repeating. Yeah, it's a pretty popular one. Those are the types of rational numbers. So let's talk about irrational numbers. What would make a number irrational? So according to this definition, it can't be written as a fraction. So it's going to be a decimal that goes on forever and doesn't repeat. Well, let's see what types of numbers go on forever and don't repeat. Non-terminating, non-repeating decimals. Yes, notability. I know those aren't words, but whatever. Non-terminating, non-repeating decimals like pi. Pi is irrational, the most popular one. So decimals that never stop and never repeat.
They pretty much don't have a pattern.
Yes. Yeah, they don't have a pattern. Now, what I mean by that is I'm not saying it can't have 2 5s or 3 5s in a row. I'm just saying that doesn't happen. On Monday, actually, we'll celebrate Pi Day. And you're going to find the Feynman point in pi, which is where you have a series of repeating numbers, but then that doesn't show up anymore. Yes?
Can we eat pie all day? Pie?
You bring it yourself. I guess so.
If we bring pie, you want us
If you bring your own pie, I'd let you eat it. Yeah.
Nice.
Just during this class. I don't know if Mr. Sylvester or Mrs. Carver would want you to do that. Yes. Pi Day's your birthday. You're also going to find your birthday in pi. So that'll be easy for you. 3.14. Okay. All right. Or non-perfect square roots and non-perfect cube roots. Remember, a perfect square or a perfect cube is going to give you a whole number or an integer, if it's a cube, as an answer. But non-perfect squares and non-perfect cubes will be irrational. So this diagram might be extremely helpful as you're classifying your numbers on tonight's homework. Rational numbers. Rational numbers can be integers, they can be whole numbers, or they can be natural numbers. And then we talked about irrational numbers, non-perfect square cubes, pi, square root of 2, -2 pi. If it's got pi in it, it's irrational, right? So let's talk about natural numbers. This is a definition you got a long time ago that you may have forgotten about. Natural numbers are the positive counting numbers. Natural numbers start at 1. Think of natural numbers as your hide and seek numbers. When you cover your eyes and you start counting, what do you start counting at?
3.
No, you start counting at 1. Yeah, you don't say 0. You start counting at 1. Those are natural numbers. Do you go to 1.5? No, you go 1, 2, 3, 4, all the way up as far as you need to. They go to infinity. Now the whole numbers are all the natural numbers plus 0. So that should have really been, the bubble should have looked like that, right? They're all the natural numbers. If it's a natural number, it's a whole number, okay? 0 is the only one that's a whole number that's not natural. And then for the integers, the bubble should have been half of it, because if you've got all the positives and 0, the other half should be all the negative numbers. So if the integers include all the natural and whole numbers and their opposites, that's that blank, they're opposites. I guess there is no blank, never mind, the positive, negative, whole numbers. It probably should say the whole numbers and their opposites, because there is no such thing as a negative whole number. I'm going to change that for next year. The whole numbers and their, well, oh yeah, I can put a blank there, and their opposites. One more? Nope. Okay. All right. If, oh, then I should probably fill in the blank. As you're staring awkwardly at me because you can't fix these. If a number, what is going on here? I understand non-terminating not being, sheesh. If a number isn't rational or irrational, then it's not real. Okay, and so we talked about 2 types of non-real numbers. If you take the square root of a negative number, it's not real. It's imaginary. Okay? In fact, I saw a meme on Facebook today, because I'm that old, that said this. It's a little mathematical humor for you. Okay, you should be able to know what's 2 cubed. 8. What do you think this says without knowing anything else? It says, I ate some pie. This is the sum symbol. You're taking the sum of a series of numbers. You'll learn about it in high school. And then, do you remember, was it yesterday or maybe it was Tuesday or Monday? Monday. I think it was Monday. We mentioned that if you're taking the negative square root of something, you could do it, but it's imaginary. So the way that you do this is you would say that even though I can't do, even though I can't do the negative square root of 1, I could think of it as the square root of 1 and then put an I next to it, so it's imaginary. What is the square root of 1? 1. So this is 1i, and if it's 1i, you could just say it's I. And so this is I ate some pie. And I saw that you could buy a shirt like that. And I'm like, I already have a math joke shirt, and I'll have to wear that one on Pi Day. It talks about, well, I'll give you a preview. It's got irrational numbers and non-real numbers. It actually just has these 2. Pi is looking at the negative square root of 1 and says, get real. And then negative square root of 1 looks at pi and says, be rational. It's so funny. If it still fits me, I'll wear it. That's not gonna be funny if I can't fit into it though.
We'll have to get him a new one.
Okay, so the second one, dividing by 0. Something you know you can't do, right? Undefined. Yeah, not real. It doesn't exist. There's no way to do that. Yeah. So here's a chart that could also be super helpful, because on tonight's homework, you're gonna have to classify numbers. Now, when you classify numbers, you have to give all the ways that number could be classified. So I want to draw your attention right now to the 4th one that says 72/4. Lizzie, use your calculator and tell me what 72 divided by 4 is. Never mind, it says it's 18. If I just read, it's 18. 18, sorry. 18 is natural. It's also a whole number. If it's natural, it's got to be a whole number and an integer and also rational. So you'd have to give all 4 of those classifications. You wouldn't just say natural. You'd also say whole number, integer, and rational. Okay. So if it's natural, it's all of them. Now, that doesn't mean that if it's rational, it's going to be all of them either. Okay. For example, 1/3. 1/3 is not an integer or whole number or natural, but it is written as a fraction, so it is rational. So you just put rational. Or in this one, negative 0.25 repeating, goes on forever, but it repeats. So it can be written as a fraction, but it's just rational, not a whole number, not natural, not integer. Okay, so give all the ways you can classify it. Let's practice that right now. Martin, I know you know your perfect squares. What's the square root of 196? 14. So this is negative 14. You can just put equals negative 14 so we can have justification as to why we're going to classify it the way that we are. Would you say that negative 14 is rational or irrational? Jimmy? It's rational. Okay. Just a capital R for rational is fine. It's rational. So if it's rational, that could mean it's an integer. Is it an integer? Is negative 14 an integer? It is, okay, so I for integer. If it's an integer, it could be a whole number. Is it a whole number? No, because it's not positive. Whole numbers are, so if you look at my number line up here, you see all these negatives that are in red? All the ones that are dark are whole numbers. All the ones that are red are integers, which so are the ones that are dark. They're also integers. But integers can be negative, positive. Whole numbers can't. Whole numbers cannot be negative. So I'd put R and I, and that's all I could put. What about this one? 0.1212212222222. Sky? It's not irrational, actually. Do you see the pattern? It's repeating 1 and then 2 and then 1 and then 2 2s. 1 and 2 2 2, 1 2 2 2 2, and we can assume the next one's gonna be 1 and then 5 2s, right? We can predict what the next number is gonna be, so it's actually rational. What about the cube root of 0? Can you think of a number times itself that gives you 0? 0. So this is 0. Is 0 rational or irrational? Xander? It's rational. Rational. Is it an integer? Yes or no?
Yeah.
Yes, it's an integer. Is it a whole number?
Yeah.
Yes. Is it a natural number?
No.
No, because natural numbers start at 1. By the way, I'm using I for integer. I'm going to use IR for irrational, just so you know the difference, okay? 0.35. Rational or irrational? Carson? Rational. Is it an integer? No. So it's not going to be a whole number. It's not going to be natural. I don't have to bother asking you. Okay. What about E? What's 58 divided by 4, Jace? 14.5. Jace, is that rational or irrational? It's rational. Is it an integer? No. So that's as far as I'm going to go with it then. Jimmy, you know your perfect squares. Is 72 one of the perfect squares? It is not. What's going to happen when I square root 72 then? That's exactly right. IR for irrational. Okay, IR for irrational. That's exactly right. Is 729 a perfect cube? You're nodding, Owen. What is it actually equal to? The cube root of 729 is 9. Owen, would you say that 9 is rational or irrational? Rational. Is 9 an integer? This is for anybody. Is 9 an integer? Yeah. Is it a whole number? Yeah. Is it a natural number?
Yeah.
Yep, it's all of them. Yep. So you know if it's natural, it's going to be all 4. You got to list all 4. What about this negative decimal that repeats? Carson?
Wouldn't it be rational because it repeats?
It's rational because it repeats. Yep. And I'll show you tomorrow how you'd write this negative decimal as a fraction, actually as a mixed number. This would be a mixed number here. Okay. All right, so let's get to the actual title of today's lesson. How much time we got? How are we doing?
4 minutes.
Excellent. 3 minutes now. Perfect. Okay, well, let me give you a quick example how to do this, and then I can review it again tomorrow. Approximating square roots to the nearest integer. How do I do that? Well, you got to know your perfect squares. Find the two perfect squares. Now, by the way, I'm asking you to do this without a calculator. Like, I'm asking you to approximate it without a calculator. Like, I'm not asking you to type it in and then tell me what integer it's closest to. Anyone could do that with half a brain, maybe a fourth of a brain. It says find the two perfect squares. The radicand is between. Now, the radicand is the number underneath the square root, right? So what's the perfect square right below 71?
64.
64. And what's the square root right above 71?
81.
81. 8 squared, 9 squared. So then it says determine which integer it's closest to. Well, the square root of 64 is 8. The square root of 81 is 9. Is 71 closer to 64 or 81? Because it's 10 away from 81. How far away is it from 64?
Less than 10. Right?
Less than 10. It's actually 7 away. So you would say it's closer to 8. What you've just seen me do is exactly what I want on your work paper. That way I know you did it and you didn't just use a calculator. Okay. The idea behind this is that on the iLearn test, during the non-calculator portion, you'd be able to do this. Right? Just tell what's integer it's closest to. That's really it. Now, to the nearest 10th, I'm going to show you a way you could do it to the nearest 10th. This one you would use a calculator on. The iLearn would not ask you to do it to the nearest 10th if you didn't have a calculator. So find the difference between the radicand and the perfect square that is closest to 0. That is the numerator. So let me tell you everything. So we said this is 64. This is 81. The reason I said find the difference between the radicand and the perfect square that's closest to 0 is because sometimes they're negative. So instead of finding this distance, sometimes I find that distance because of the negative number line being completely flipped backwards. Okay. We said the distance between 64 and 71 was 7. That's my numerator. Now remember, we said this is closest to 8, right? So 8's this. Okay, so it's gonna be 8 and 7 something. 8 and 7 over something. To find what that something is, sorry, this is really repetitive. If I put 64 and 81, you would have known it. The answer to the previous one, though. So 64 or 8 and 7 over, and then what's the difference between 64 and 81? Because what you're finding is part of the distance over the whole distance, and that's exactly what a fraction is. What's the difference between 81 and 64? You can use your calculator, Maddox. 17. All right, so it's 8 and 7/17, but it said to the nearest 10th. So I take 8 and 7/17. I divide using my calculator. So you're not going to have this question on a non-calculator portion of the iLearn. 7 divided by 17 is 0.41. So 8.4. Makes sense? So I guess you can find the fraction, the mixed number of that approximation without using a calculator, but to turn it into a decimal, you would use a calculator. All right, we'll pick it up from there tomorrow. Have a great day. All right, the square root of 460. Can someone tell me what two perfect squares 460 would be between? The next smallest, the next largest. Yes, Jacoby. I'm doing the first problem. I think you're looking at 24. It's okay. Do you know your perfect? I don't know. Do you know your perfect squares up to around the 400s? Have you gotten that high yet? No, you've got a little bit of time. You got till next Friday. I do have a list of people that have already done it. Lucy was one that did it today. Lucy, can you tell me perfect squares? What's the one that's right before 460? 441, 444, 441. Sorry if I can say it, which you said was 21. All right. So 21, which means the next obvious one's 22. Jimmy, what's the square, or the 22 squared, I should say. 484. So those are the two perfect squares it's between. 441, highlighter, and 484. So that's why it's important that we know our perfect squares if we're wanting to ever approximate, especially without using a calculator. All right. Now the question is which one is it closer to? How do I find which one it's closer to? Carson?
Whichever one like has a smaller distance.
Okay, and you say distance.
I mean, like
How-
distance on like a number line.
Okay, and how do you find the distance between two numbers?
Well, you probably take 460 and subtract 441 from its five distance and 44 minus 460 by the distance.
Okay, cool. So what's the distance between 441 and 460? While you're working on that, 19, okay. Oliver, can you tell me the distance between 460 and 484? $24. All right, so Oliver, is it closer to 441 or is it closer to 484? So is it closer to 21 or 22? 21, yeah. So which integer is it closest to? We'd say 21. See how that's done? Got to know your perfect squares and then figure out which one it's closest to. So we can do that. What about example B? I've got the negative square root of 24. Am I allowed to put a negative sign outside the square root? Some head nods. Am I allowed to put a negative inside a square root? Why not? Does he explain? Okay, it's not a thing. Why is it not a thing? Emerson, why is it not a thing? Yes, so Emerson is explaining that when you square a number, which means you times it by itself, it can never be negative. Because if you're squaring a positive number, positive times positive is positive. And if you're squaring a negative number, a negative times a negative is a positive. So the number underneath the square root symbol is not allowed to be negative. It's not a thing. You're right. What will your calculator say if you ask it to do the square root of a negative number? What will it say, Xander? Domain error, something like that. Yeah, saying, no, dummy, I'm not going to do that, right? Yeah, well, it's okay. Sorry, I didn't mean for that calculator. I didn't mean for that negative to go into there. The negative on the outside just means I want the negative version. And remember, every square root has two versions. Because if you square root a positive number, it can be positive, or because a negative times a negative can be positive, you can square it and it can be negative. So this is just asking for the negative version, or in this case, negative integers. Just keep that in mind. We're on the other side of the number line right now. Yes.
Tell me why is it like an error though? Because like if you square like -2, yeah, I mean it would be 4, right?
Mhm.
So like
Yeah.
why does it make the error? Why can't it just be like, oh, that's 4, you're stupid, but it's 4.
Well, it is a computer. It's not a person. So it's probably not going to say, hey, dummy, or something like that, right? Yeah. So it may know what you think it means, but it should also remind you that you're not allowed to have the negative under the square root, right? So I'm kind of glad that it says that. So you're like, oh, what did I do wrong? I typed the negative underneath. So keeping in mind that the numbers on the negative side of the number line are bigger on the right side than they are on the left side, because we're flipping it around. What perfect square is just bigger than 24 and which one is just smaller? Alex, which perfect square is bigger than negative square root 24? Bigger. I phrased it that way for a reason. Yes, -4, because -4 is bigger than, okay, so we've already determined then it's -4, -5. Let's go back one step. Let's take it back one step. What two perfect squares do we need to write down? Deegan? Okay. So again, the reason I wrote the 25 on the left side and the 16 on the right side is according to our number line, bigger numbers are always on the right side. Negative square root 16 or -4 is bigger than -5. So that's why I'm writing it like that, okay? Now, Alex, back to you. Which of those perfect squares is negative square root 24 closest to? Yeah, do I need to like break down and show you how far away they are? Can we just realize it's one away, right? It's one away. So it's going to be really, really close to -5. Now, if I were rounding it to the nearest 10th and I needed the whole number and one more decimal place, what would my whole number be? Forget the decimal place. What would my whole number be? Is this going to be negative 5 point something or negative 4 point something? Lucy? Yes, it's closer to negative 5, but it's not quite negative 5. So if you had to give an approximation, would you say this is negative 4 point? What do you think? It's really close. It's the nearest tenth. What would you say? Xander?
9.
Negative 4.9. It's about as close as you can get, right? Negative, yeah, I'd say it's probably right. Can you use your calculator, Xander, and tell us exactly what it is? Or not exactly, because we know it's going to be irrational, never end, but you could give us like the first few decimal places.
Negative 4.8.
Negative 4.89, so it would round to negative 4.9, but negative 4.89, and then what's the next one?
8.
8, so it's really, really close, yeah. Does that make sense? So just because it's closer to negative 5 doesn't mean if I ever actually wrote the decimal down that I put negative 5, put negative 4.9 in this case, negative 4.89 or whatever. Okay, so a couple more problems and we'll switch to today's, I told you today's lesson's not going to take us very long to do. It says the radius of a circle with an area A is approximately square root of that area divided by 3. The area of a circular mouse pad is 51 square inches. Estimate its radius to the nearest integer. Okay, what do I do with that 51 square inches? Brady? Simplify 51. Okay, so you're saying go ahead and plug it in for A. You guys agree with that? Is that our area? How do I know it's my area? Does it say? Yeah? How is it labeled? What kind of units are they using? Inches. Isn't that it? That's also another dead giveaway. This is our area number. Good. So I'm going to plug that number in for that A right there. Oops. Now I can't draw an arrow apparently. So square root of 51 over 3. Brady, you said simplify it. What is 51 over 3? Okay, so square root 17. So it wants us to round it to or approximate it to the nearest integer. So here's square root 17. What's the perfect square right below square root 17? Christian? The perfect square. 16. Okay, so I wrote your 4 down. That's right. And the one right above 16. What's your next perfect square? And what's its integer? 5. Okay, so Carter, would you say square root 17 is closer to 4 or 5?
It's closer to 4.
Good job. Closer to 4. Okay, closer to 4. Now, before we move on, it says the radius of a circle with an area A is approximately square root A over 3. That's true for every circle. How are they getting that? How are they getting that? Square root area over 3. How do you find the area of a circle? What's the formula? Pardon, do you remember the area formula? What is it? Pi r squared. Okay, so they're saying that if I find the radius of this, the radius that I would to find the radius is area over 3 and then the square root of that. So let's see if I can try to get something similar to that with this formula that Martin just gave me. What's the first thing I would do to try to find the radius? What might I do first here? You guys did this I guess it was a few chapters ago. We found the radius of a circle given its area. What would you do, Brady? That's what I would do. Divide by pi. Divide by pi. So now we have, I'm going to draw an arrow. We've got A over pi equals radius squared. Garrett, what would I do now to get r by itself? Square root both sides. So according to this, to find out what the radius is, I would do square root capital A over pi. What did our problem say? It didn't say square root capital A over pi. What did our problem say? Why do you think that is? Xander.
Around 5 to 3.
You see where they got their square root a over 3 now? They didn't pull that out of a hat, right? That came from the area formula of the circle that you guys have already done. And it said if you approximate it, is 3 a good approximation of pi? 3.1, right? Yeah. So on Pi Day, on Monday, we're going to do a web quest. You guys are going to be looking at the different facts about pi. You're going to find out that pi over the course of years has been, I guess, hasn't necessarily changed. The value is never changing, but people have suggested that we use different values for pi, including 3.2. What state do you think suggested we use 3.2 for pi? Texas?
Indiana.
It was Indiana. Why? You'll have to find out when you read that on Monday.
I guess it's
Because
Texas
not
because
many
I'm-
mathematicians doesn't make.
Not too many smart mathematicians in Indiana. All right. Next one, the distance.
Mr. Bright.
There's one, right?
Yeah.
It's not me. The distance in nautical miles you can see with a periscope is 1.17 square root h, where h is the height of the periscope above the water. Can you see twice as far with a periscope that's 6 feet above the water versus a periscope that's 3 feet above the water? Let's calculate both and see if it's twice as far. So both of them use the same formula of 1.17 square root h. So if my periscope is 3 feet above the water, we're going to plug in 3 for h. And if it's 6 feet above the water, we're going to do 1.17 times square root 6. Do you agree that if it's 6 foot over the water, it's twice as tall as it was when it's 3 foot over the water? Okay, so we need to see if this also makes it twice as far, distance-wise, in those nautical miles. Okay, you can use your calculators here. We're not going to do any approximations. Dawson, I want you to do 1.17 times square root 3, and I want you to give me 2 decimal places. Chloe, I want you to do 1.17 times square root 6 and also give me 2 decimal places. What do you get, Dawson? 2.03. So he can see 2.3 nautical miles with his periscope 3 feet above the water level, sea level. What'd you get, Chloe? .86 nautical miles. Is that twice as far? No. Does squaring a number mean timesing by 2? No. Common misconception though. You know how many times I've had to deal with that with the other classes? They're doing area of circles right now. I'll say, what's 3 squared? You know what I get a lot of? 3, yeah, 6. What is 3 squared? Why are they making that mistake?
Because they think it's 3 times 2 and not 3 times 3.
But does squaring a number mean times by 2?
No.
No, so it's pretty obvious here that you can't see twice as far for that very same reason. Okay, all right, we're done with that. Did anyone have any homework questions?